Today is the day that you are going to learn about trigonometry for the first time. Trigonometry starts out by talking a lot about right triangles and the functions sine, cosine, and tangent. Sine, cosine, and tangent. Those are abbreviated on your calculator as sin, cos, and tan, but it's important that you know sine, cosine, and tangent. What they do is they relate angles to side lengths in ratio form. A couple things that I need to get out of the way just so you're going to be able to follow me later is, first, it's pretty important to know which angle you're talking about. We're relating an angle, a specific angle. It's going to be one of the acute angles. We aren't going to do this on the 90. So we're going to pick an acute angle, and once we know which angle we're thinking of, then we should be able to identify which side of the triangle is the hypotenuse. If we're thinking about a specific angle, we can talk about what side is opposite that angle. The side opposite that angle doesn't even touch that vertex, so it's way over there. And the third side, the other leg, is the adjacent side. So that's kind of the first step. You're going to have to be able to identify those. Here we've got one of our classics, 45, 45, 90. So this is a 45-degree angle right here. And if that's the 45 we're looking at, we would consider this one the hypotenuse. And then the opposite would be the one that's way across. This would be the opposite side from that angle. And adjacent would be the other one, the one that's right next to it, but not the hypotenuse. Now that you understand that, I can actually teach you about trigonometric ratios. Remember, it all is based off of an angle. So here's the Greek letter theta. So sometimes instead of using an x, you're going to see them using a theta to stand for angles. These are the three functions we're learning about: sine of theta, cosine of theta, tangent of theta. And like I said, those functions, all it does is it relates a ratio of two side lengths. This is something that you're going to have to memorize, this little box. Luckily, it's kind of an easy thing to remember because somebody once made up this sort of memory tool. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So anytime you talk to somebody about trigonometry, you're going to hear them say SOHCAHTOA. SOHCAHTOA. You'd have to be able to spell that, but that's going to help you remember which trig function goes with which ratio. When I look at these three triangles down here, just as an example, all three of these triangles, I built them so that they would be similar to each other, which means all of the angles are congruent and all of the sides are proportional. So those are all similar triangles. There's a reason for that. I'm going to make a point about that later. But what we're going to do is we're going to try to use one of these trigonometric ratios on these angle thetas. So when I look at this triangle, I can see that this is my hypotenuse side. If I'm at angle theta, the opposite is way over here, and the adjacent is the 9. It's the one that's right here. Now they didn't give me any information about the hypotenuse. I could Pythagorean theorem it, but let's just focus on what we can do without having to do that. We've got an O, we've got an A. We've got a 3, we've got a 9. Which one of these could we set up with just an O and an A? And that would be the tangent ratio. So the way you're going to write that is you're going to write tangent, or just tan, of angle theta. You can do the parentheses or not, it doesn't really matter. Tangent of angle theta is the ratio, it's equal to the ratio of TOA, opposite over adjacent. So it's a 3 to 9 ratio. The tangent ratio of this angle is 3 to 9. I don't care if you reduce it. 1 to 3 would be just as good. On this one, if I set up a tangent ratio, Okay, so tangent, again, is going to be opposite over hypotenuse. We have the same orientation here. Here's the I said hypotenuse, I'm sorry. Tangent is opposite over adjacent. So kind of the same setup on this one. Tangent of that angle is 4 over 12. Again, you could leave it like that, or you could reduce it. If you reduce this one, you get 1/3. Is there some reason that we got the same ratio for both of those? That should make sense, because I told you that these thetas, if these are all similar triangles, these are all congruent angles. So the tangent of this angle is 1/3, and it's still 1/3. It doesn't matter what type of triangle I draw with it, as long as it's a right triangle. And one more time, if this is my theta, here's my opposite way over here, here's my adjacent. So it's easy to set up a TOA, opposite over adjacent. Noticing that that's still 1/3. All right. I'm just going to recommend that at the top of your worksheet you write so, ka, toa, and maybe pronounce it with those H's in there. Let's try some problems. So you need to know which angle we're focusing on, and in this example we've labeled the angles. So I've got angle A here. Which sides are labeled? I've got not the hypotenuse, but the opposite side and the adjacent side have numbers. And we did that before, remember? If you have an opposite and an adjacent, you should be setting up a tangent ratio. So the tangent of angle A, TOA, is 6 over 11. That's all we're doing. We're setting up tangent ratios, sine ratios, cosine ratios. On the next one, angle B is our focus. You'd have to know what sides those are considered. Well, this is the hypotenuse. And if we're up at angle B, what would side 10 be? It would be the opposite side. So then I'm going to want to pick one that has an O and an H involved, and that's sine. So for this one, I'm going to write sine of that top angle B equals, so 10 over 14. And I really don't care if you reduce that. Let's keep going. Again, always checking to see what angle you're on. If I'm on this angle, I know that's the hypotenuse. This would be the opposite, so that must be the adjacent. I've got an H and an A. So the only one of these three that has both an H and an A is the cosine ratio. Cosine of angle B, ca, A over H. Just setting up our ratios. I didn't label an angle on this one for some reason, so let's throw an angle in there. Let's say we're going angle A down here. Paying attention to which angle we're on. This would be hypotenuse. This time, if we're down at angle A, this is our adjacent side, since opposite would be over here. So again, we'd have an A and an H. A and an H is a cosine. Cosine of angle A, ca. So the A over the H. I hope you're catching on to this. Next, angle A, hypotenuse. Way over there, opposite. We have an H, we have an O. The only good choice is sine. The sine function of angle A, so would be 2/6. I don't know if you're wondering this, but this actually winds up being really useful for solving problems later. But for right now, we're just trying to get a grasp on how to set them up. Here's angle B up here. It looks like I don't have my hypotenuse. I have the opposite side way over here, across from B. I have the adjacent side. Looks like I'm going for a TOA this time. So I have to write tan, short for tangent, tangent of angle B, TOA, equals 8/3. So that's a lot of what you're going to need to be able to do today. We should probably also talk about how we're going to do a couple things on our calculators. For example, if I wanted to find out what the sine of 50 degrees is, on my calculator I type the sin button, sine 50. On yours, depending on what kind of calculator you have, it's possible that you would type the 50 and then the sine button. And I should get a ratio. It'll only put it in decimal form. Now, if you're not getting the same thing as me, it's probably because your calculator is in the wrong mode. We want to be in degree mode because I just said 50 degrees. So somewhere on your calculator, you should have some sort of mode or settings button. And on my calculator, you can see down here, we've got radians versus degrees. Sometimes there's another option too, but on this one you can see that I have my degree highlighted. If I were on radians, I'm going to get actually the wrong answer. So you'd want to check, and if you're not sure how, play with it, check with a friend. But here's a good one to try. If you can get on your calculator sine of 50 degrees is 0.766 ... then you know you're in the right mode. And so there's a few on your worksheet that are going to just have you play with that. Good luck, and I will have you watch another video tomorrow.